All right. Had interruption, a phone call. Um, but okay, let's try to get to the juicy stuff. Apologize for the laconic form of expression. Um, I'm gonna try to speak a little faster. So, anyway, one of the interesting things, or interesting, not interesting, about taking measurements is a leaf, because of its shape, is very difficult to measure outside of its simple, uh, width and height. And of course, by making an impression or tracing it, is a good way of capturing the whole dimension of the piece. But for the purposes of this, to try to figure out how much stuff is in the leaf, we need to prepare the leaf. So if you measure the widest point, so let me see, well, that's not all right about here is the widest. So I don't know, but it's possible that we'll scribe right through it. If it's a leaf, I doubt if that's going to happen. But anyway, I made an impression on the leaf about halfway through, and I need to cut it. And this is in preparation to prepare it for measurement. So you want to cut the bottom half from the widest, from the width, and then you need to cut the leaf upper half, the top half, sorry, in half. All right. So now we got our leaf divided into 3 sections. Now let's turn this clay slab. And every measurement, like I said, as for our senses, which are also designed to measure, every measurement needs some reference point. And in this case, I think I'm going to use the width of my pinky, the last digit in my pinky. So I'm going to use my pinky as reference. So that's the width of this digit, this knuckle. And I'm going to mark it on the bottom there, and then I'm going to scribe a horizontal line, a line that's horizontal to the landscape, horizontal. Now this pinky width, boy, that looks really fat for my pinky. Yeah, I guess if I kind of smush it out, will be my reference point. Now, what we'd like to do with the leaf, to make the leaf more measurable, an easier thing to measure, is turn the leaf into a rectangle. So if I put the bottom half of the leaf on my pinky line, and I take the upper halves and turn them upside down and invert them, I can start to make a rectangle. And what I'd like to do, you can see this is a rectangle. So what I'd like to do, though, is try to minimize this space. And the way I can do that is overlapping. So the amount of overlap of these two, of the leaves of the top half and the bottom half, start to compensate, or imagine would occupy, this negative space here. So what is the shape of that rectangle? So I am sort of guesstimating, which is, you'd be surprised how good people are at sort of doing. So let me see how much is underneath here. How much is underneath here? So I don't know, that looks like that would fill those two spaces. So let's see. It's just, then they have a little bit of overlap here. So we have more than enough, I think, that fills up. So that, basically that rectangle, now the leaf is into a rectangle. And of course, and this is an easier shape to measure. So I can measure its height, its width. And what I'd like, next step I'd like you to do is then measure the width, which is about here, and draw a line. Let me see. Clean this up just a little bit. Being a little. Get this. There we go. So there. Whoop. Doing what I'm supposed to be doing here. Too much coffee. There we go. Okay. So basically we're boxing in the shape and we're extending certain measurements throughout the clay tablet. These are extensions of the width. And now we're creating an extension of the height. There. And these are, and we'll just clean this up just a little bit more. I like it to look nice. Okay, so now we have our leaf. And the next step with the Mendeleev dividers is to take the carbon to cellulose. This is from periodic table. This thing feels a little wiggly. There we go. Just tightened it up a bit. So with the broad face, the wider section, the longer legs of this divider, you will measure the height. Then you reverse it, which is the amount of cellulose to the ratio, or the amount of carbon. So the other end represents carbon. And what you'll want to do is mark it on your clay. And with your smaller divider, which you have a little bit more control to use, capture that measurement and transfer that across. So this, from here to here, which is I believe, a ratio of actually 4 to 9. 4.5 would be half of 9, but it's just shy of half is carbon. Now what's left? I forgot to mention that cellulose is made up of carbon, hydrogen, and oxygen. So what is remaining? So if we've got all the carbon, what's remaining are the hydrogens and the oxygens. So that's when you take the Mendeleev water divider, and this divider is water, a ratio of water to hydrogen. The wide part is water, H2O, and the is hydrogen. So measure the remaining. So they made it that one. That looks about right. Now this little bit, mark it. The clay, your clay tablet, and then take your divider, measure the width of that, and then scribe across. Well, if I think I moved my divider, I can feel it. There we go. Now, this little width is hydrogen. Now what's left? Well, this amount is, if cellulose is made of carbon, hydrogen, and oxygen, and this is oxygen. And so this is the amount in this leaf. And the most abundant of all the elements, the most amount of, is oxygen. Not by much, but it's, and that's also true for the human body. So even though we're like 90% water, but water's made of hydrogen and oxygen. So oxygen is the most abundant in plant leaf, and it's the most abundant in us of all the elements.